This is Mrs. Milton. Welcome to my basement. I'm here today to try to make some videos for you for section 7.3, where you learn about the law of cosines. The law of cosines is a lot more straightforward and simple than the law of sines. So if you made it through the videos from 7.2 for law of sines, this should feel pretty good and straightforward. So stay with me, watch these, and before you know it, you will understand and know how to use the law of cosines. Thanks so much. For a quick review, when we used yesterday the law of sines, that looks kind of silly. Let's just write it in. All right. The law of sines is when you had an angle, side angle situation with your triangle, where your triangle would maybe have an angle and another angle, and then it would be the side included between the two that you would have information about. So an angle, side angle situation would be law of sines, and then an angle, angle, side situation, you would use law of sines as well. So if you had the same two angles, but now this time the side that's picked is only touching one of the angles. It's not between the two. So maybe it's this side, the information you would have, that would be an angle, angle side, or this side would also be an angle, angle side. It just can't be the side that's between the two angles. And then the third situation that makes law of sines so much trickier is SSA. I like to call that donkey. So I remember that that's the tricky one. So side angle would be, let's say you had these two sides picked and only one angle. It could not be the angle between the two sides. That would be like the vertex. Maybe it would be this angle here, where this angle only touches the one side, not the other. And then what happens, why side angle is so tricky, like we saw in the videos yesterday, it could either actually make 0 triangles, 1 triangle, or 2 triangle. So when you get the donkey situation, that's the tough one to deal with. Not tough, it just takes longer. All right, and then today we're going to talk about the law of cosines. Or LOC, we could call it for short. You'll use law of cosines if you have something like a side angle side triangle situation. So that's where the two sides and the included angle. So if it was this angle that was included, it would have to be these two sides that we have information on. The angle has to be touching both sides, or a side situation where you knew nothing about the angles, but you knew all three side length pairs. So those are the two situations we'll see today in law of cosines. And then a quick review. In our triangles, we kind of like to visualize them. We'll tend to draw a triangle that's not accurate, but to remind you that uppercase letters are reserved for the side lengths, and then the lowercase letters are, uppercase letters are reserved for the angle measures. The lowercase letters are reserved for the side lengths across. So if this is angle A, side length A across would be here, side length B, and side length C is how we will do our labeling. So uppercase letters for angles, lowercase letters for side lengths. All right. So this is actually the law of cosines comes in two parts. The first part is if it's a side length you're trying to find. So I would label your notes by saying you're trying to find a side length here. So notice it's lowercase a. So this is if you're trying to find side length A, you would use this formula. If we were at school together, then I would ask people to try to find some patterning to see if they could tell me what it would look like if you were finding lowercase b, and what the formula would look like if you were finding side length C. And usually many kids in the class are able to see the patterning that when you're finding A, it was B squared plus C squared. So for finding side length B, we'll do A squared plus C squared. And then instead of minus 2BC, we'll do minus 2AC times the cosine. If this was angle A, we'll do the cosine of angle B. And then side length C, we'll have A squared and B squared minus 2AB times the cosine of C. So the truth is, for these three formulas, if you know one of them, you know all three of them for finding a side length. So make sure you have these written down. This is really nice to use. Law of cosines, finding a side length. All right. Now the question is how can we change this formula to be when we're finding an angle measure? So law of cosines, I would label this next part. Just like finding a side length, there's going to be three formulas, one for angle A, one for angle B, one for angle C. But if you know one of them, you've really got all three of them. All right, but here's the challenge. Like when we go back to this first one, we've solved for a side length, lowercase a. I want us to use our algebra skills to try to solve for capital A. If you are inclined to challenge yourself, I would pause the video now and just give it a shot. See if you can solve, if you can manipulate this and solve for angle A. If you don't want to challenge yourself with that, just keep playing and follow along as I go through it. So here's your chance to pause if you want to give yourself a challenge. All right. If you want to see now, how will we solve for A? Well, first things first, I want to get rid of this square root. So if I square the entire right side, the root and the exponent of 2 will cancel, but I have to balance my equation. What I do to one side, I have to do to the other. So I am at a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. So I still have a ways to go to get this a alone, but it's already looking a lot better. I think next I'm going to subtract b squared and c squared over to continue to try to get that capital A alone. So I have a squared minus b squared minus c squared minus 2bc. No, equals a negative 2bc times the cosine of A. All right. Remember, our goal is really to get this alone. So we're getting a lot closer. So the only thing that's really left to do is to divide both sides by a negative 2bc, because they will cancel over here. And now what I'm going to do is I'm just going to kind of flip these around so the cosine of A is on the left. That's easier for me to deal with. And I'm going to put the a squared minus b squared minus c squared in parentheses all over that negative 2bc. All right, now I'm going to play around with this just a little bit. I don't really like having this negative in the denominator, so I'm actually going to move it up here, because really this negative, you could move out in front, and then what a lot of times mathematicians do is move it into the numerator. So if I clean this up just a little bit, I'd be at the cosine of angle A, and let's go ahead and distribute that. So I have a negative a squared plus b squared plus c squared over a positive 2bc. The only reason for that step really is to take this negative and move it up to the numerator, which is just a little more common. So there was nothing really that changed that much there, but it's a step. All right. And then I still don't really like how this looks. I don't like this negative in front. So this step isn't necessary, but it does explain where things come from. Plus c squared, or it explains why the formula ends up being what it is. Then all over 2bc. All right. Then the last thing we learned is it's finally time to get this a alone. This a is representing an angle. So we need to split it up. How do you get rid of a cosine? Is you take the inverse cosine. So basically here, to find angle A, we're going to do the inverse cosine of b squared plus c squared minus a squared all over 2bc. And that is the formula for A. And then just like for our side lengths, once you know one of the formulas, you know all of them. So to find angle B, see if you can find the pattern. We're going to do that inverse cosine, only this time it will be a squared plus c squared minus b squared all over 2ac. And then if we're looking for angle C, we're going to have the inverse cosine of a squared plus b squared minus c squared all over 2ab. All right. So officially, mathematicians actually would say that right here is the official formula, and they would write all three of them as cosine of A with all this stuff, cosine of B with all this stuff, and cosine of C. I just took it one step further to remind yourself that to split up the cosine and the angle, you would use the inverse. All right, so the law of cosines has these three formulas to find an angle measure, and these three formulas to find a side length. Please tune in to video number 2 where I'm going to do a few examples. Thank you.